Hello everyone. Today we are going to discuss about quicksort. Uh, Quicksort is a sorting technique which can be implemented using divide and conquer strategy. What is divide and conquer strategy? If the problem is smaller, then you need not to divide the problem into sub problems. If the problem is large, then we will divide the problem into number of sub problems, and each subproblem will get solved individually. Later, all the subproblem solutions will get merged to get the final solution. So this is what actually the idea of divide and conquer strategy. Now, quicksort we are going to implement using divide and conquer strategy. One important point is, in quicksort we'll apply divide and conquer, but we will not have merging solution. Let us see how quicksort will be implemented using divide and conquer strategy. In quicksort, the division into two subarrays is made so that the sorted subarrays do not need to be merged later. This is accomplished by rearranging the elements in A of 1 to n such that A of I lesser equal to A of j for all I is between 1 to m and j is between m plus 1 to n. For some m, always m lies in between 1 to n. Now, the elements in A of 1 to m and A of m plus 1 to n can be independently sorted. Now, when you are getting the solution independently of two sublisters, no merging is needed. The rearrangement of the elements is accomplished by picking some element from the array, say that t is equal to A of s, and then reordering the other elements so that all elements before appearing t in the array are less than or equal to t, and all elements appearing after t are greater than or equal to 2t. So this rearranging is referred to as partitioning procedure. Partitioning procedure is what? So with this you can understand that quicksort is needed two things. The one is what? We will be considering any element as pivot element. Now our job is what? Find the perfect place of the pivot element. What is the perfect place? When you choose this is the perfect place, then this left side of this element should be less than from this element. The right side of the element of this should be greater than. Now the list can be sorted. So this is what actually quicksort. When it seems not it in perfect order, then we will go for interchange. So there are two operations what are required. Choosing the perfect place of pivot element by approaching through partitioning process. The second is interchange of the elements. With these two procedures, we will be implementing the quicksort. Okay. Now we'll see recursive approach of quicksort pseudocode. That is, I'm taking quicksort function where quicksort function requires two, you can take even array starting index and ending index. Now we will be going to sort the elements A of p to A of q, that is the starting index to the ending index, which resides in the global array A of 1 to n into ascending order, where an plus 1 is considered to be defined and must be greater than or equal to all the elements in A1 to n. Now, if p less than q, that means what? The problem is not smaller. If the problem is smaller, then it is p equal to q. When it is p less than q, that you can expect the array is having some number of elements. Now you have to divide the problem into sub-problems. How can I divide the whole list into sub-problem? you have to take one element which is j, which will help us to make partition of the list. Now partition is a p q plus 1. So this is what partition. Now so with this partition procedure, what we will do is we'll find the perfect position of the partitioning element. That is, we'll find the perfect place, sorting place of the pivot element. Now after you find the place for pivot element, you can solve the sub problems. Now what are the sub problems? Quick sort. Based upon the pivot element position, we will be making the list into two halves. Let us suppose this is our j. Now this array is from 1 to n. So 1 to j is already sorted. This is what we done through partitioning. This is what we done through partitioning. Now j is already sorted. You need not to again look forward j. What you have to do, quicksort algorithm has to be recursively applied from 1 to j minus 1. Next j plus 1 to n, as j is already sorted. Now quicksort j plus 1 comma q. Now so I did not written any combined solution because we are individually sorting, right? So there is no combined solution, or there is no merging of solution to quicksort. Now we'll take some example and we see how quicksort will be executed. We'll take some example. Now the example, some elements I am taking. There is no need that you have to take the same example. Now so I am taking this list of 5 elements. So now I am going to apply quicksort on these elements. You can take or you can consider any element as pivot element. Make sure if you are considering this element as pivot element, left of this element should be less than of pivot, right of this element should be greater than of pivot. Now if I am considering this as pivot element, now this is the perfect place of pivot element, as such that all the right hand side of elements are greater than this element. So this is the perfect place. Now there is no sorting applied for this, right? Now our sorting will be for the list A of j plus 1 to the n. From this area to this area you need to apply the quicksort recursively. So this is what the example of one set of elements. You can take the other set of the elements, something like 6, 3, 5, 4, 2, 1, 9. There is no constraint in the order of taking the element, but make sure, prefer to take the elements which are unsorted fashion. Now this is one set of elements. Now here you can take any element as pivot element. I am considering this as my pivot element. So when you are saying that pivot element place, this is the correct place, make sure that left side of element should be less than the pivot, right side of element should be greater. As far as the example is concerned, this is the correct place of pivot element. If it is not correct place, make sure by applying partition procedure, make sure that the elements of left should be less than, right should be greater than. Now we'll take the other example. Now this time I am taking some example. Now this time I am considering middle element as pivot element, or it is not maybe middle, but I am taking this as my pivot element. Is this correct place of pivot element? I have to do that through partitioning procedure. So how partitioning will help you is, you have to compare this element with the next element. Okay, when you are comparing this element, if this element is greater, you required greater elements right hand side. So when you have right hand side this element, no exchange is required. Simply you increase the index. That means from this area to this area, index will get moved. Now here you have 16. So 16 is the right place. After 10 only 16 should be. Now the same 12 should be also the, you have to compare with the pivot I said. So 10 is greater 12, 10 is less than 12, 10 is less than 13, 10 is less than 14. Now pivot is in the right place. So this is the way how you have to do the consideration of pivot element and finding the perfect starting place for the pivot element. Now we'll see how partition will take place. We'll take one more example before we go to partition. Now this time I am taking some example where I am considering the first element as pivot element and the total list is unsorted. So I told you already, there is no constraint to take the list of elements in this order. You can take any order, any number, any element. It's your wish. So starting with the, so this is my this is my low index, this is my high index. So high here denoted with infinite. Why the reason I am taking it is a maximum size. To tell it is a maximum size, I am denoting with infinite. So in programming, while you are writing a programming, you can take a maximum number, something like 1000 you can take as maximum size. Now, so now array is consisting of total how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 elements were there in the array. Now, so can I make this element as pivot? Yes, you can make any element as pivot element. And make this very sure that right side should be greater than the pivot. Now, so when you find lesser elements are also there here, then what is your job? You have to move this element to left side of this. So what we have to do is, we will be pointing two indexes. One is starts with low index, the other is starts with high index. Now the intention of this I is what, or the job of this I is, I always will search for an element which is greater than the pivot. J always search for the less than the pivot element. Now what we will do is, we'll point I here, we'll point J here. Now, so 20 greater 26. So it is in the right place. So don't do anything. No exchange is required. Simply you increase the index. Now I plus plus. So again what you have to do is J with this, J minus minus. So 15 should be right hand side, correct? So 19 here. So now you have to make the comparison. So 26 versus your 15. So as far as 26 is greater than the 15, you should make exchange, that a of I less than or is equal to a of j. Now a of I, if it is lower value, let it be. If it is higher value, make exchange. Then if you exchange these elements, 15 will come here, 26 will go here. Right? Now the same. So now this time you will be checking the same with the 18 index. Index will get incremented, index will get decremented. And until you find the correct place of your pivot element place. So that is what, how long I should do this process? How long I should do this process is till I cross j. Till I cross. By the time it comes closer to I, one such time I will cross j, right? And that is the pivot place. So this is what actually quicksort. In the next example, we will see how partition algorithm will work and we'll find out the complexity of quicksort. Thank you all.